resolution of 2 volts per division, or in this case, vertical division. So from one line to the other, horizontal, it's going to be 2 volts, okay? In this case, channel 2, it's off, so that's why it says no, basically. So the other thing is we can move, in this case, the position, so that we can see how basically displays the signal, if we want to see separate signals or if we want to just put one over the other. Now, in terms of the vertical divisions, we have time division. So right now it says that the resolution is 40 milliseconds per division, okay? So we have from here to here, there will be 40 milliseconds, okay? In order to see that everything is working properly, what we can do is just, the oscilloscope have its own proof signal that it comes from here. It says that it's a 5-volt square wave. So then this is the proof that we use. This always goes to ground as a reference, and this is the signal. So in order to be able to attach this to the circuit, you must just push here, or pull, and then you will see how there's a small like how do you say, like a hook that will just attach to the component. So then in this case you will get the reference to the ground, and then in this case the signal to the signal. So right now, for example, you can see that this one it is actually a signal of 1 kilohertz, that it's going too fast. So again, you're not able to see it. Fortunately, with this one, you can move the scale of time so that you can separate and see multiple waves or less waves in the oscilloscope. So right now I'm moving to the right, so I'm expanding it, I'm zooming the signal, and as you can see, I can see multiple waves on the screen. And if I don't want it up, I can just move here with the position. So for example, right now what you can see is that this is not an AC signal. What is not AC? Because it's not crossing the zero. The arrow here of the channel 1 indicates what is the zero. So right now it starts from that point up. So that means in this case we have a DC, right? A DC signal, that it's just on the positive side. So then, as I told you, in this case, this is going so fast, so you're not able to see it. Let's say if we apply the signal to the LEDs, we're not going to be able to see that it's actually, what is the time that it takes. So one thing, remember I told you that each division is 2 volts. So then if I count here, so it's going to be 2 plus 2, it's going to be 4, and then a little bit more, which is going to be 1. In this case, will give us 5 volts. So if I wanted to see clear, I can move it a little bit down, right? And I can use a vertical scale so that I can increase the size of the signal. But right now, it seems that it's going too slow, so we need to go function. The sensitivity right now is fine. Let's move to coarse. So then, in this case now, we can just move it faster. Okay, so right now, let's see, we want to see the signal on the whole screen, so we just, well, in this case was too much, so we reduce it. And we can see it more clear. Right now, in this case, the resolution says that now we have 1 volt per division, so we can count 1, 2, 3, 4, and 5. So right now we can see that actually has a little bit more than 5. However, if we just want to have a more precise measurement, we can use the cursor, okay? For the cursor, it's basically these 2 lines that we have here. The cursor you're gonna use for time, as it's selected here. So let's say you want to measure the period of the signal, so you can start moving the cursor to a specific point on the screen. Let's say in this case, whatever we start. Now, as you can see on this one, with the course, it just jumps the beginning and the end of the signal. So you can go back to function and then set it to fine, so that you can return to cursor and move it to specifically match the beginning of the signal. So now we have the, in this case, the cursor to start directly there. So we can just push the node, and then it will now move the cursor to the other part. So in this case, I'm gonna start moving it so that I can measure the total time difference that I have here between the waves. okay, the one cycle. So if you don't want to stay moving like this, you can change to course again and then just return to find once you are near to the signal. So right now let's see there. So for example, here it says that the time difference is 992 microseconds. Okay, that's the period of the signal. So then in this case, once you develop your measurement, right, you will take that. The period of the signal is 992 microseconds, and then the frequency will be the reciprocal of that. Okay. Any question that you have? So in this case, nothing complicated. In this case, if you want to move the signal on screen vertically, you can just use the vertical position, right? If you want to increase the size of the signal, so you can increase in this case with the vertical scale, right? If you want to see more or less waves, if you want to see less waves, so you just turn to the right, and you will see less waves on the screen. If you want to see more waves, so you just turn to the left in the scale for horizontal, and then you will see more waves in the time. Of course, as you're moving, the scale on the cursor will also change. Right now, for example, it says that the time difference is 4.92 milliseconds, but at this point it already includes multiple waves on the same measure. Okay? So once you have your circuit, basically you can connect or hook this one to any of the LEDs on the output, or directly to the output of the pin 3 on the chip. So then you can just connect it, and then you can take this one to the ground so that you can visualize here the signal. Okay? Questions that you have? No? Okay. Great. So breadboards are already on the test.